Hi there. Okay, we're going to talk about everything we need to know about VT graphs. So sorry that this kind of got cut short in our class, but it won't take us very long. And as you've watched the video already, and now we've done the activity where we built one ourselves, this should go pretty smoothly. Okay. So first of all, what is a VT graph? This means velocity, time. Okay, and velocity time graphs tell us acceleration. Okay, so first up it says a horizontal line represents an object that is moving at a constant velocity. Okay, so if I take my ruler and I draw a horizontal line in the upper area, I draw a horizontal line in the lower area, okay. This upper area means that we're moving forwards. Okay, any lines that appear below the x-axis mean that we're moving backwards. Okay, this V here stands for velocity. Right, and the T stands for time, and that's 0. Okay. Right on. Next up, number 2. An object is not moving when the graph is at 0. Okay. So now I'm going to take my line and I'm going to draw it right on the x-axis. Okay, as long as something is on the x-axis or cutting the x-axis, it stops moving. Okay, because that would be 0, right? So here we have a positive velocity getting larger and larger and larger velocity in a positive way, and here we have a negative velocity that's getting larger in a negative way, and then right at the line is 0. There's no velocity. Okay. A change in direction is indicated by the graph moving from the positive side to the negative side, or vice versa. Okay, so as soon as we cross the x-axis right there, that is our change in direction. Okay. So before, it was when we had a peak, okay, or a valley for a DT graph that told us a change in direction. Here, it's as soon as we cross the x-axis, okay? Everything on top is going forward, everything in the bottom is going backwards, okay? An object is slowing down when the graph approaches 0, either from the positive side or the negative side of the graph. Okay, so if we have a line like this or a line like this, okay, here we are slowing down, okay, because the velocity is approaching 0 over time. Okay, we're moving backwards, okay, and here we're going forwards, but we're also slowing down because the line is approaching 0. An object is speeding up as a graph moves away from 0. Okay, so now slightly different. Okay, so now if we have a line that goes up and away from 0, we can tell that that is speeding up. Okay, because as we look as time goes on, the velocity increases. And if we have a line in the underneath the x-axis, okay, that's going down in a way that means our velocity is also increasing. Okay. A straight and angled line represents constant acceleration. So remember, the slope on a DT graph tells us velocity. The slope on a VT, velocity time graph, tells us acceleration. And as long as the line is straight and angled, straight and angled, okay, then we have constant acceleration. Okay, if it was a horizontal line, there'd be no acceleration because the velocity is on cruise control. It's just staying the same. Okay, let's turn the page over. Okay, a curved line represents non-constant or changing acceleration. Okay, so for example, if we had a graph that looked like this, okay, we can tell, same thing like we did on a DT graph, right? If we were to kind of chunk this up into even sections, we'd be able to see that the distance between each section, the line is longer and longer, which means that the velocity is not the same, which means we have changing acceleration, okay? Acceleration can be calculated by finding the slope of a tangent line. So this tangent line still comes in handy here on a VT graph. If I wanted to calculate, for example, how fast we were going right there or what my acceleration was, I would line up my graph right to just barely touch it. I would draw a straight line. Then I would take any 2 points on that line and calculate the slope. Okay. And then I would be able to find the acceleration right at that point. Okay. If there was a curved line, a tangent, oh sorry, this should be straight line. If there's a curved line, a tangent, the fancy name for a straight line, is drawn and the slope of the tangent is calculated. Okay, and here's something pretty cool. Although we can't tell where we started from on a VT graph, we can calculate the displacement by calculating the area under a curve, under the graph. So for example, I'm just going to draw a very quick little graph here. Okay. 1, 2, 3. It is literally super, super small. Let's go 1, 2, and -1, -2. Okay, so here is, say, the path of a dog or the velocity of a dog. Okay, if we calculated this area and we calculated the area of this triangle and we calculated the area of this triangle, we could find out how far they went in 1 second, how far they went in, let's say, 1.7 seconds, and then how far they went in 0.3 seconds. That's pretty cool. And you already know how to calculate the area of a triangle, so it actually wouldn't be very hard to do. Okay, so let's take a look and see if we can draw some graphs. Okay, so on the next page I have 4 graphs, and it says transforming between DT and VT graphs, draw the shape of the missing 2 graphs in each task. And we're going to do these like this. We're going to do this one first, then we're going to do number 2, then we're going to do number 3, and then we're going to do number 4, or then we're going to do number 3 last. Okay, so we're going to take a look at this one first because this is the easiest graph to look at. Okay, so we want to take a look at, we have a VT graph here and we want to change it into a DT graph. So I'm not worried about numbers or anything, we're just generally trying to understand what the graph would look like. Okay, so if I have constant velocity here and I'm moving backwards, okay, so backwards and constant velocity would mean that, I'm just gonna make a little notch for myself here so I can line them up, that I would have a line that's going down and to the right on my dt graph. Okay, down and to the right means that I have constant velocity and I'm moving backwards. Constant velocity, moving backwards. Okay. Now this section here means that I have constant velocity, but I'm moving forwards. Okay, so my graph ends about here. Okay, so constant velocity moving forwards. There we go. So this dt graph would be the dt graph for this vt graph. Okay. So the easiest way to do this is just to do it in sections. Start with one section, draw the graph, do the next section, draw the graph. Okay, so let's take a look at number 2. Okay, so this one is harder in that it has curved lines, but I'd say it's easier because we're going from a dt graph to a vt graph. Okay, so the first thing we want to know is that right here, wherever the curve kind of bottoms out, here we have our velocity is 0. Okay, so I'm going to make a note of that in 2 places here. Okay, so our velocity equals 0. Okay, and we also have kind of 4 little sections. Okay, so I'm going to kind of draw these out so I can keep them separate. And I'll just make a gentle note on my graph below. Okay, so I can kind of line them up. Okay, so if I take a look in this section, right, I have a velocity that is slowing down, okay, but going forward. So slowing down and going forward. Okay, so that means I'm going to have a VT graph that looks like this. I'm slowing down and I'm going forwards. Okay. The next section, well, my velocity starts at 0 and is increasing. Okay. Starts at 0 and is increasing. Okay, so now I'm going to start at 0 and I'm increasing, but I'm also going backwards because my line goes down and to the right. So now I'm going to go down to the right. Okay, and now this section here is still down and to the right, so I'm still going backwards, but now my velocity is slowing down. Okay, so I'm going from fast to slow. Okay, so from fast to slow. Okay, and then my last section here, I'm going from slow, so no velocity, or sorry, yes, I'm going from no velocity and I'm speeding up, okay? But I'm speeding up, okay? So, and I'm moving forwards. I'm going up and to the right, okay? So then that would look like so, okay? So that was the next easiest one to try. Okay, let's take a look at this one. So task number 1, okay, it has 2 line segments. So I'm just going to make a note here on the middle of the first graph. And we're going to take a look here. Okay, so here we have a constant acceleration. Okay, so our velocity is changing and we're going forwards. Okay, so we're starting from a fast velocity. Okay, because remember here, we're starting from a fast velocity, we're away from 0 and we're approaching 0, okay? So this would look like a curved line that comes up like that, okay? So we're starting from a fast velocity. It's not that we start at 0, that doesn't matter. The fact is that we have a curve here, right? If I were to split these into little sections, we can see here lots of change happening and then we are slowing down. Okay, so same thing here. Lots of velocity and then we are slowing down. Okay, and the next section, here we're moving backwards and we're speeding up. Okay, so if you guessed it, we are moving backwards and we're speeding up. Okay, same thing again, right? Very low velocity here. Okay. Makes sense. Very low velocity here, and then we're getting faster and faster. Okay, The steeper the slope, the faster the velocity. Nice. Okay, so that was the third one. Now the fourth one. This is, I would say, the hardest one. So here we have two segments, and it is nicer because it's going from a DT to a VT graph. So in this graph here, we're moving forwards. And in this graph, we're moving backwards. Okay, I think we can both agree on that. We move up and to the right, it's forwards. Down and to the right, it's backwards. Okay, so now on a VT graph, if we look just at this segment, okay, so we have a low velocity, and then it gets faster and faster and faster, and we're moving forwards. Okay, so low velocity, faster and faster and faster, moving forwards. Okay, now here, we're moving backwards, and we start at a high velocity, and then we're going to zero. So we start at a high velocity, and we're going to zero, but we're moving backwards. So that graph would look like that. Super counterintuitive, because we would never draw a graph like that. But that's what this would look like. Okay? I guess we could kind of curve it and then draw a straight line that came down to that. Okay? Yeah. So on the next page, on the back side, are 4 tasks. Okay? So you have a VT graph, and then a DT graph, and then another VT graph, and then another DT graph. I would like you to try these 4, and we will go over them when we come back to class next week. Thanks.